Hi, my name's Aaron, and today I'll be talking about how to represent a sinusoidal wave as both polar and rectangular format. The general mathematical representation of a sine wave is given as A sine omega t plus or minus beta, where A is the amplitude, omega is period, and beta is the phase difference of the wave. The given wave is mathematically represented by the equation shown. This format is useful for representing a sine wave. However, when it comes to AC circuit analysis, using the given form is a tedious approach, thus using complex numbers to make it not so complex. So we must be able to convert the waveform to polar and rectangular format. In polar format, the wave is represented as magnitude and direction, where r is the length of the vector and beta is the direction. For our previous wave, the polar representation would look something like this. Now we convert to polar format for situations where we need to multiply or divide sinusoidal waves. In the example, we will need a polar representation of these waves as we are dividing. Thus, simply use the amplitude of the waveforms to represent the magnitude and the phase difference to represent the direction. Both are highlighted in red. Now just divide the magnitudes and subtract the angles. So leave us with 3 at an angle of 90 degrees. Now just simply convert back and that's the final product. You would usually require RMS values of the voltage when converting to polar form, but since we're staying simple, let's keep that out. Now, you can obtain this by dividing the amplitude by square root of 2. In rectangular format, the wave is represented as a complex number. To obtain this, you're gonna need to convert to polar first. Then use those values. The values are found using simple trig, where x is cosine 45 and y is sine 65. Oh, 6 sine 45. This form is used in addition or subtraction of sine waves. So, in the example, we would first convert to polar representation, then to rectangle. I skipped the polar step, but if you're struggling, just jump back a bit into the video and review it. Now we punch those numbers into the calculator, solve the problem, and then convert back to polar form. Then back to sinusoidal representation. To convert from rectangular form to polar form, we find the magnitude from the complex numbers by finding the hypotenuse, and then the direction is found by using the x and y values. Now I hope you're still awake and have learned something today. Cheers for watching.